Okay, so we're doing this question on vectors, which says that with respect to origin O, the points A, B, and C have position vectors given by this, this, and this. The point D is such that ABCD is a trapezium with DC equals 3 times AB. Find the position vector of D. So what we'll do is, for part A, let's write this equation. Again, DC equals 3 times AB. Okay. Now I'm going to break these into their position vectors, difference of position vectors, which is going to be OC minus OD equals 3 times OB minus OA. So OC is already known, 3 minus 2, 2. Negative 3, negative 2, 2. Minus OD is what we're trying to find. So just keep it as OD equals 3 times OB minus OA. 1 is 0, 4, 1. Minus OA would be minus 2, minus 1, plus 3. So we get minus 3, minus 2, 2 here, minus OD equals, we'll get a minus 6, we'll get a 3, and we'll get a 4. Now make OD the subject and subtract these two position vectors, column vectors. So it would be 3 minus 2, 2, negative 3, negative 2, 2, and minus 6, 3, and 4, which gives us 3, negative 5, there is a mistake somewhere, which is right here. We get a negative 6, then we get a 3 times 3, which is a 9. Sorry, I overlooked that. And then we get a 4 times 3, which is a 12. So let's fix that. Okay. And then we have a 9 here and a 12 here. Let me just rub this and write 9 and 12 instead. And now when we subtract this, we get a 3, then a negative 11, and then a negative 10. That is the value or the position vector of OD in column vector form. But since the question was in IJK form, we write 3I minus 11J minus 10K equals OD. Part B says the diagonals of the trapezium intersect at P. Find the position vector of P. All right. So let's see. All right, so let me just make the diagonal. It says that DC is 3 times BD. The DC is 3 times AB, so we'll have something like this. This would be A, B, and C and D. Let's say this is the trapezium. Okay, now the diagonals intersect at P. So this is first diagonal, this is the second diagonal, and they intersect at P. And we need the position vector for P. So first we'll need to form a vector line for AC, then vector line for BD, and then solve them simultaneously to find the point of intersection. Okay, let's start. So I'm going to form vector equation for AB first. AC first. So for AC, R is going to be, take the position vector of A and take the position vector of C. I'm going to take A first, so then I write 2, 1, minus 3 plus lambda, and now I need to do C minus A. So that is going to be -3, -2, -5, then -2, -1, -3, and then 2 minus -3, 5. So this is the vector equation for AC. Now I need the vector equation for DP. So R equals, I would like to take B first. So B is 041 plus mu times. Now we're going to do, since this was B, we're going to take D minus B. And we already have D. D is 3 minus 11 minus 10. And from that we subtract B. So it's going to be 3 minus 0 first. So that would be a 3. Then it's a -11, -4, which is going to be -15. And then it's a -10 and a -1. So that's going to be a -11. This is the vector equation for dB. Now let's solve these simultaneously. Okay, to solve them simultaneously, we write them together. So 2 minus 5 lambda, 1 minus 3 lambda, minus 3 plus 5 lambda equals, I'm equating the R's equals to 3 mu, 4 minus 15 mu, and 1 minus 11 mu. Now use the first equation and the second equation to simultaneously solve and get the value of lambda and mu. Let's see. So 2 minus 5 lambda is equals to 3 mu, and 1 minus 3 lambda is equals to 4 minus 15 mu. Rearrange and you would get minus 3 lambda equals 3 minus 15 mu. Okay, you're going to solve these two simultaneously. This one, equation 1, and this one, equation 2. And once you've done solving them, you'll get mu is equals to 1 by 4 and lambda equals 1 by 4. Both will come out to be 1 by 4. Okay, now it's up to you whether you want to substitute lambda here or mu here and get the value of the three points of intersection. I mean, one point of intersection, x comma y comma z. Okay, so I'm going to substitute it in here. So mu is 1 by 4. So then I get 0 plus 1 by 4 times 3, that's 3 by 4. Then I get 4 plus 1 by 4 times minus 15, that would get us 1 by 4. And then we get 1 plus 1 by 4 times minus 11, that gives -7 over 4. So now we write it as a position vector. So OP equals 3 over 4i plus 1 over 4j minus 7 over 4k. And in the last part, we have to use a scalar product to calculate the angle ABC. So ABC is this angle. So we may write outwards angles. So if we're using the outward direction, it's going to be cos theta equals BA dot BC upon magnitude of BA times magnitude of BC. Okay, so we do already have AB, I believe. Yeah, this was AB, look. This was AB, so this was AB, -6, 9, and 12. Now I need BA, so I'm going to flip these signs and write 6 minus 9 minus 12 dot I need BC now. So for BC, I'll have to do a bit of working. No, hold on, that's not BA, that's a mistake. BA is here before we multiplied 3 with it. So that's a -2. Let me write that here. So in fact, this is AB. AB was -2 and a 3 and a 4. And we need BA, so we're going to flip the signs and write 2 minus 3 and -4 with the change signs. Okay, dot. Now we need BC. Let me do the working for BC here. BC is OC minus OB. Let me, in fact, do it on the right side. So BC is OC minus OB. So if I do that directly, it's going to be this minus this. So we have a -3, we have a -6, and we have a 1. So dot -3, -6, 1. Let's write down magnitudes of both of them. So for BC, the magnitude would be square root of 3 square plus 6 square plus 1 square, that's 46, square root of the 46. And here we have AB's magnitude equals 2 square plus square root 2 square plus 3 square plus 4 square. That's a 29. Now let's apply dot product in the numerator, -6 plus 18, -4. That's an 8. So 8 upon square root of 29 times square root of 46 equals cos theta. And we need to find the angle. So take cos inverse of this. So theta will come out to be 77.3 degrees. It's up to you whether you want to give answer in radians or degrees.